Hey, how you doing? I know there's people out there that get sad when they hear my voice instead of lovely Dobby, but you're stuck with me again here on 6.3, looking at our properties of exponents. Most of the things we're going to talk about here are stuff that you did back in Algebra 1, but who remembers Algebra 1 anyway? Especially if you had me, you probably don't remember anything. Alright, so we got things like 2 cubed and 2 to the 5th. What we need to remember is that 2 cubed literally means, 2 times 2 times 2. 2 to the 5th, so we got another 5 2's. Oh, that was horrible. Alright, so how many 2's do we have? 1, 2, 3, 4, 5, 6, 7, 8. So it's really 2 to the 8th. So we're looking at what is the shortcut, because nobody wants to write this out. How do we make the 3 and the 5 into that 8? Well, let's take a look at these things here. 2, 2, and then 5 of them. 1, 2, 3, 4, 5. How many do we get? Well, it's 2 to the 7th. 1, 2, 3, 4, 5, 6, 7 of them. So this is literally just counting them up. So what do we need to do in order to make that a little easier? Instead of writing out all 3 threes and writing out all 6 threes, just add those together. So we get 3 to the 9th power. I think you can figure out these other ones here. What's this one going to be? 7 to the 7. And here, 4 plus 4 is going to make 8. So that's just one of our little properties that we go through here. How does that differ when we have a fraction? Well, 2 to the 3rd over 2 to the 1. If you got a 2 over a 2, that cancels. So what's left? 2 squared. So here, 1, 2, 3, 4, 5, 6 of them over 1, 2. So 2 cancel. 4 of them left. 2 to the 4th. So what are we really doing here? We're just subtracting, right? 6 minus 2, 3 minus 1. So whatever our number on top is, we subtract our number on the bottom, and that'll help us out. Well here, how does that going to work here? We got 3 on the top, 3, 4, 5, 6, 7 of them on the bottom. Cancel, cancel, cancel. So we're left with 2 to the 4th on the bottom. Well, what's left on the top? If nothing's there, it's going to be a 1. Alright, so here's your properties. So you're multiplying, that means you're going to add your exponents, m plus n. If we're dividing, you're going to subtract them. The big thing here is these have to be the same bases. You can't be like x to the 4th, times y to the 3rd. That's not going to make some kind of crazy xy to the 7th sort of hybrid thing. No, that's just silly. You can only do it if your bases are the same. And here, last one, is our power to a power. This is like when you have x squared to the 3rd. What that means is you've got x squared 3 times. Well, what's 2 plus 2 plus 2? That's x to the 6th. Well, how can we make that easier? Take these two and you multiply them. 2 times 3 gives you 6. So that's what that's showing you right there. Alright, this guy here is kind of like distribution. But I hate saying it because it's very, very bad to go x plus 2 and distribute that square because of the plus sign. That's one of my least favorite things people do all the time. You've got to do box method and go back to do all that horrible stuff from before. But if we have like 4x squared, we can kind of distribute that to both of those two things and get 4 squared x squared. Again, I'm gonna say distribution just because that's kind of what our memories are going to draw on, but it's not really distribution. It's just kind of like everybody gets a little 2. Here, with our division, it doesn't matter. The m is still the power for both, so everybody gets a little m right there. So let's just kind of go through some. Oh, we got more. I forgot. 0 power. Anything to the 0 power is 1. X to the 0 power, 1. 4, 2, 6, 8, 9.4915 to the 0 power is 1. It doesn't matter what this crazy number is. You put it to the 0 power, you get 1. It's just what it is. And negative powers drop things to the bottom of the fraction. So if I have like x to the negative 2, What that really means is x is going to be on the bottom with the normal positive 2. This tends to be one of the more confusing things because the negative sign disappears when you switch it down to the bottom. It's kind of like you have x to the negative 2 over 1, so we're going to flip it over, but that negative becomes positive once it's down here on the bottom. And once you get used to it, it's pretty easy, but it's one of the trickier things. So what do we have going on here? 7 to the third, 4 times. Well, add them all up. We're going to get 7 to the 12. What's our easy way to do it? Multiply 3 times 4, 7 to the 12. Alright, this guy. Oh, goodness. So, we're going to kind of get everybody gets a little 3 happening here. Negative 3 to the third. We get x squared to the third. Y to the fourth to the third. So what are all our powers doing over here? This is going to be multiply. 2 times 3 gives us x to the 6. 3 times 4 gives us y to the 12. And negative 3 to the 3. Remember, odd powers, this is old school here. Odd powers, the negative sign stays. So negative 3 cubed, like so. Or if you want to write it out, you can get what's 3 times 3 is 9, times 3 is negative 27 then. X to the 6, y to the 12. Sometimes with the smaller ones like this, like an x cubed or maybe a 4 cubed, we're going to write out the number. If this was like 9 to the 8th power, no, we're not going to write that number out. We leave it as 9 to the 8th. So here, what are we going to do? There's a couple different things you can think about it as. You can think about it as y to the 6 minus y to the 8th equals y to the negative 2. And what does the negative do? It goes to the bottom, like so. If we want to write it out, we got 6 y's on top. I'm already regretting writing these out. 1, 2, 3, 4, 5, 6, 7, 8. So, who gets canceled? Bam, 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 bam. 2 of them left on the bottom. Get you that same answer there as well. This is why our subtraction works and why that negative stays there, because that means those ones are left on the bottom. Alright, this is the one that's going to fool kids on the test all the time. 0 power. You're like, it's just 4 times 1. 4. I'm telling you, it's the easiest trick question that we can ever put on a test. I swear. Alright, all kinds of negatives going on here. Well, first off, this negative is out in front of the 4. That is different than saying negative 4 to that negative 3 power. In which case this now does matter with that negative sign. But here, this negative is out here on its own. It's just there. It's just hanging out. So what does this negative 3 do? That sends it to the bottom of a fraction. So we get negative 1 over 4 cubed. This does not get affected by the power. Alright, here. Is this negative 6 got anything to do with that 4? No. Again, parentheses make all the world of difference. If this was written in parentheses, then yes, that 4 is going to make that 6 very different. But the way it is written, no, that 4 got nothing to do with the 6. So I'm going to write my negative 6. And this negative means my x is going to be going down here to the bottom, and that's going to be my answer. If you want to put that negative out in front like this, that's the same thing. Either way is fine. I like sticking it up here just because you kind of don't lose it. Sometimes you get it lost out here. You don't want to lose your negatives. It's one of the worst things to happen on a school day. Alright, so here. Going to kind of get everybody gets a little 2. So we're going to get r squared on top. Here we're going to have power to a power. This is a multiply situation. If you want to think about it as s to the 5th squared and rewrite it that way, that's what's happening. In any case, we're going to get s to the 10 here on the bottom. Nice. I hate s's in the problem. My s's, my 5s, they look the same. Neither one of them looks nice. They're both ugly. Oh goodness. This is what's going to scare you on a test, is because we're going to give you a whole bunch of crap like this. We've got to deal with it now. So let's just go part by part. 3 over 6. Does that reduce? Yeah. That's a 1 over a 2. And I'm just going to write them there. Go part by part. Hey, this x doesn't have any power on it. That means it's a 1. Remember, there's always a 1 there. It's kind of like we always have 1x to the 1 all over 1, like, to the 1. You can put powers and multiply and divide by 1 all over the place, and nothing really happens. So, we got 2 x's on top. We got 1 on the bottom. 2 minus 1 leaves x to the 1. Here, we got y on top and bottom. We got 4 minus 6. So this is kind of like y to the 4 minus 6 is a y to the negative 2. So where's that going to be? That's going to be on the bottom. And when I write it down here, that negative sign doesn't come with it. We leave it behind. The negative means go to the bottom. So we got our x's done. We got our y's done. We're left with these z's. 8 minus 2 leaves us with a z to the 6th power. Look at that. That's nice and easy looking. And you could even get rid of those 1s. We could write x z to the 6 over 2y squared. And that looks even better. I like that. Good answer. Good answer. Example number 9. I really encourage you to hit a pause and try it on your own, but you probably aren't. And I don't want to leave you with this. This is kind of crazy looking, so let's go through it anyway. 6 over 9. What's that going to reduce to? Well, divide them both by 3. We get a 2 on top and a 3 on bottom. X's. We got x to the 15 minus x to the 7, so 15 minus 7. So leaves x to the 8th, and that's going to stay on top because it's positive. Y's now. Y to the 12 minus negative 2 goes here. What does minus minus do? Well, you can't be too negative. You got to smile and be positive. So 12 plus 2 is going to make y to the 14th power. And lastly, my z's. So we got z to the negative 4 minus 4. Well, that makes z to the negative 8. And where's my negative power going to go? It's going to go down here on the bottom. Z to the 8, and I do not bring the negative with it. The negative says go down, so it goes down there and stays. 2x to the 8, y to the 14 all over, 3z to the 8. Not so bad, not so bad. And hey, look at that. 12 minutes and we're all done. Well, I'm sure you can realize that it's going to get a little tougher from here, but you're going to be alright. Make good choices, and we'll see you on the next one.